बच्चों अब मैं चैप्टर ड्यूअल नेचर ऑफ मैटर एंड रेडिएशन की समरी रीड करूंगी. The minimum energy needed by an electron to come out from a metal surface is called the work function of the metal. Energy greater than the work function phi naught required for electron emission from the metal surface can be supplied by suitably heating or applying strong electric field or irradiating it with by light of suitable frequency. Photoelectric effect is the phenomena of emission of electrons by metals when illuminated by light of suitable frequency. Certain metals respond to ultraviolet light while others are sensitive even to the visible light. Photoelectric effect involves conversion of light energy into electrical energy. It follows the law of conservation of energy. The photoelectric emission is an instantaneous process and possesses certain special features. Photoelectric current depends on first the intensity of the incident light, and second the potential difference applied between the two electrodes, and third the nature of the emitter material. The stopping potential V naught depends on first the frequency of the incident light and the nature of the emitter material. For a given frequency of incident light, it is independent of its intensity. The stopping potential is directly related to the maximum kinetic energy of electrons emitted. E V naught is equal to half mv max ka square is equal to k max. Okay. Below a certain frequency, that is called threshold frequency, nu naught, characteristics of the metal, no photoelectric emission takes place, no matter how large the intensity may be. The classical wave theory could not explain the main features of photoelectric effect. Its picture of continuous absorption of energy from the radiation could not explain the independence of K max on intensity, the existence of mu naught, and the instantaneous nature of the process. Einstein explained these features on the basis of photon picture of light. According to this, light is composed of discrete particles, packets of energy called photons or quanta. Each photon carries an energy E is equal to h nu and momentum P is equal to h upon lambda, which depend on the frequency nu of incident light and not on its intensity. Photoelectric emission from the metal surface occurs due to the absorption of a photon by an electron. Einstein's photoelectric equation is in accordance with the energy conservation law as applied to the photon absorption by an electron in the metal. The maximum kinetic energy half mv max square is equal to the photon energy h nu minus the work function phi naught is equal to h nu naught of the target metal. Okay, so this is given the value how to find the kinetic energy, maximum kinetic energy. The photoelectric equation explains all the features of the photoelectric effect. Millikan's first precise measurements confirmed the Einstein's photoelectric equations and obtained an accurate value for Planck's constant h. This led to the acceptance of particle or photon description of electromagnetic radiation introduced by Einstein. Radiation has dual nature, wave and particle. The nature of experiment determines whether a wave or particle description is best suited for the understanding the experimental result. Reasoning that radiation and matter should be symmetrical in nature. Louis Victor de Broglie De Broglie attributed a wave-like character to matter, means material particles. The waves associated with the moving material particles are called matter waves or de Broglie waves. The de Broglie wavelength lambda associated with the moving particle is related to its momentum p as lambda is equal to h upon p. The dualism of matter is inherent in the de Broglie relation, which contains a wave concept lambda and a particle concept momentum. The de Broglie wavelength is independent of the charge and the nature of the material particle. It is significantly measurable for the order of the atomic um, material particles. It is significantly measurable of the order of the atomic planes spacing in crystal only in case of subatomic particles like electron, protons, etc. due to the smallness of their masses and hence momenta. However, it is indeed very small, quite beyond measurement in case of macroscopic objects commonly encountered in everyday life. किसकी बात हो रही है? लैम्डा की. Electron diffraction experiments by Davidson and Germer and by G.P. Thomson, as well as many later experiments, have verified and confirmed the wave nature of electrons. The de Broglie hypothesis of matter waves supports the Bohr's concept of stationary orbits. This table is also very important. Planck's constant given by h, dimensions, then unit, and then remarks. H is equal to h nu, unit joule second. Stopping potential V naught. E V naught is equal to K maximum. Work function phi naught. फिर उसके dimensions, electron volt and joules. E K maximum is given by E minus phi naught. Threshold frequency nu naught hertz. So de Broglie wavelength lambda is equal to h upon p. De Broglie equation. Read the points to ponder.